let's evaluate this limit. So we have the limit of f of x over g of x when x approaches infinity. So first, I'm going to use the properties of limits. It says that the limit of a quotient is equals quotient of the limits. So I can rewrite this limit as limit of f of x when x approaches infinity over limit of g of x when x approaches infinity. So basically we have this quotient of the limits. The numerator we have to find the limit of f of x when x approaches infinity, and in the denominator we have to find the limit of g of x when x approaches infinity. So I'm going to replace f of x by the given function. So this will become limit of x approaches infinity. Replace f of x by 2x plus 3e power negative 5x. And in the denominator we have the other limit, that is the limit of g of x when x approaches infinity, and this is already given as infinity, so we can utilize this value. So therefore I put infinity in the denominator. Now let's evaluate the numerator limit. So before that I'm going to rewrite this expression, that is 3 e power negative 5x. This can be written as 3 times of 1 over e power 5x, and then this divided by infinity. Now let's apply the limit, that is we let x approaches infinity into the expressions. So when we do that, we replace x by infinity, that is this becomes 2 times of infinity plus 3 times of 1 over e power 5 times of infinity, and this is over infinity. 2 times of infinity, which is a large number, so it's let's say it is infinity, and 3 divided by this expression, that is e raised to the power of 5 times of infinity is a large number, so we put this as infinity, and this also is infinite because when e approaches infinite, that is in this expression, when x approaches infinite, the exponential function approaches infinity. So this is equivalent to 1 over infinity, that is this expression, and 1 over infinite is 0, that is 1 divided by some large number. We can see that it approaches 0, so we replace this by 0 and we get infinite over here. So we are now getting into this form, that is infinite over infinite. So this is basically an indeterminate form. That is one of the indeterminate forms out of 7 indeterminate forms. So when we encounter this kind of indeterminate forms, we use L'Hopital's rule to evaluate the limit. We use the L'Hopital's rule. So let me state the L'Hopital's rule. That is, when we have to find out the limit of a quotient expression, that is f of x by g of x, when x approaches infinity, and if we end up with infinite over infinite, or one of the several indeterminate, or one of the 7 different indeterminate forms, then we apply this L'Hopital's rule. It states that this that is this limit is equivalent to limit of f prime of x, that is the derivative of the function in the numerator, divided by the g prime of x, that is the derivative of the function in the denominator. So this is what L'Hopital's rule says when you encounter any indeterminate forms. So we are going to apply this in the L'Hopital's rule to our limit. So let me rewrite our limit. We have a limit x approaches infinite. Let me replace the f of x. F of x is 2x plus 3 e power negative 5x. So when we apply this rule, we have to find the derivative of f of x. So I'm going to put this in derivative notation, that is 2x plus 5 e power negative 3x raised to the power of that is this is derivative. The small tick marks indicates that it is derivative. We are going to find the derivative. We'll do that in the next step, and this has to be divided by limit x approaches infinity g prime of x. So this equals, we'll find the derivative of this expression, and this is equal to limit x approaches infinite. Derivative of 2x is 2, and derivative of 5e power negative 3x. We can do this by using the chain rule. So I put the constant 5. Derivative of e raised to the power of negative 3x is e raised to the power of negative 3x. And then when you apply the chain rule, we find the derivative of negative 3x, which in fact equals negative 3. So it is 5 times of negative 3 is negative 15, and then e raised to the power of negative 3x. So the derivative of 5 e power negative 3x is negative 15 e raised to the power of negative 3x. Let me put this to the right so we will have some better view. So I keep it like this. Now let's continue, and then we have to divide by the derivative of g prime of x. And this is already given, that is the derivative of g prime of x. We can utilize this expression, that is 1 over x. So I'm going to put limit x approaches infinity. This is 1 over x plus 4 cos phi over x. So this is 4 cos phi over x. And we put a bracket to indicate that we apply the limit as completely. Now let's apply the limit. That is, we have to let x approaches infinity for both the numerator as well as the denominator limit. So when we do that, we get 2 minus of 15 e power minus x. I can do it over here, negative 15. I write this e raised to the power of negative 3x as 1 over e raised to the power of 3x, and we let x approaches infinity. So therefore 3 times of infinite is this is infinite, and negative 15 over infinite, this is approaching 0, because any number over infinite, e power infinite is infinite, so any number by infinite it approaches 0. So overall, the when you apply the limit, this approaches 0. So I put a 0 here, and then divided by, now we apply the limit to the denominator limit. So here we have 1 over x. So I put a 1 over infinite plus 4 times of cos of 5 over infinite. Let's evaluate this. We know that 5 over infinite approaches 0, and this 1 over infinite, this also approaches 0. So we get 0 plus 4 times of cos of this approaches 0, so cos 0. We know cos 0 is 1, so 4 times of 1 is 4. So in the denominator, we have only 4. Now this reduces to 2 fourths, and this equals 1 half. So we have finally figured out the value of the given limit, that is 1 over 2. So choose choice B as answer.